Tiende pamoja ndi mtima umo. 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 Tiende pamoja ndi mtima umo.
Teleschool. My name's Anton Samanenga. I'm pleased to be on this MTN platform to help you prepare for your final exams through revision of past papers. I'm a specialist in mathematics, and today we'll look at a few questions from the same papers. But as we start the revision, please remember to tag your friends and family so that they can be able to join us in watching the live stream on mathematics. You can also drop a comment and also tell us how everything is going out there. Right, so for now we continue from the first session. We are going to look at question 14 from paper 1, 2017 General Certificate of Education. And question 14 is based on ratio, proportion, and variation. Now, the question reads, the table below shows the relationship between two variables, x and y. It is given that y varies inversely as the square root of x, where x is positive. Now, this topic is on variation. There are different types of variation that you need to put into consideration. There's what we call direct variation, inverse variation, as well as joint variation. In the question that has been asked, we've been told that the two variables, they vary inversely. But before we go into the actual solving of the question, let's remind ourselves about variation and the like. So what is direct variation? When two quantities vary in such a way that when one increases and the other one increases, then the two quantities are in direct proportion. And if we have two quantities varying in such a way that one increases and the other one decreases, then the two quantities are in inverse variation. And so the question that we are looking at today is in inverse variation or inverse proportion, where one quantity increases, the other quantity decreases. We can cite an example of a woman who is in a kitchen, maybe trying to prepare some lunch and only has 3 pieces of meat, preparing for 3 people, but in the process 3 more people enters and then they had to join them for lunch. So you discover that the 3 pieces of meat remains the way they are and the number of people increases. So as the number of people increases, the pieces of meat reduces. That's a perfect example also which we can use for inverse variation. How about joint variation? This is simply variation where two or more variables are connected together, either directly or inversely. So you need to have that background whenever you are solving questions concerning direct and inverse variation. So let's get back to our question then to see if we can answer the question that has been given. The table below shows the relationship between two variables x and y, and it is given that y varies inversely. So here, one quantity is increasing and the other quantity is decreasing. So we are saying y varies inversely. And to show that one quantity is increasing and the other quantity is decreasing, we are going to say y varies inversely as x. This means we have two quantities, y and x, which are varying inversely. As one quantity increases, the other one decreases. But now let's first understand what the question is saying. The question says, it is given that y varies inversely as the square root of x. Y varies inversely as the square root of x. Here many of you or many of the students make mistakes. We're going to say y varies inversely as the square root of x, and not y varying inversely as this. Usually, students mix up these two, square root and x squared. In this case, we are talking about this relationship or variation that is taking place. So please do not make a mistake of thinking square root of x is x squared, because that's where most of us make a lot of mistakes when we're answering these questions. So, where x is positive, and now we've been given a table. Let's get back to the question. We've been given a table. Allow me, that's a table given there. Let me also draw it somewhere here so that you can be able to follow. We have x and y, then we have 2, we have 8, and we have 8 over 9, and then we have 16, we have 1, and we have a. Right, so here now we've been asked, question part A states, write an expression for y in terms of x. Write an expression for y in terms of x and the constant of variation, which is k. Now, before we go to writing an expression, let me give you an example of this. If one book costs 2 kwacha, 2 books will cost 3 kwacha, 2 books will cost 4 kwacha, and 3 books will cost 6 kwacha. You can see that as the number of books increases, the cost price also increases. And then you are also going to bear with me that the difference here in terms of the amount is 2, there is 2 here, there is 2 here, and it continues. 4 books will cost 8 kwacha. The difference is still 2. So this 2 is representing the constant of proportionality. The 2 is representing the constant of proportionality. And in mathematics, this constant of proportionality is given or denoted by the small letter k. And when you go to the question, they are saying write an expression for y in terms of x and the constant of variation, which is k. They want you to also give the constant of proportionality. So let's look at now. They just want us to write an expression in this case of y. So since they are varying inversely, we're saying y varies 1 over the square root of x. So since they're in inverse variation, we're going to say y equals k over the square root of x, where k is the constant of proportionality. Right. I guess you get it now. So this is what they're expecting us to do in question part A. They are just simply asking us for an equation that is connecting the variables, which is y and x. And then in the next question, they also ask us to find the value of k. So this equation, which includes the constant of proportionality, is the one that will help us now to answer the questions that follow. So when you look at the given table of values, we have x, the x value, which has 2, and the corresponding value of y is 16. We have the x value of 8, and the corresponding value of 8 is 1. We have the x value of 8 over 9, and the corresponding value is a. Now, the question reads, find the value of k. We are going to use these 2 pairs of coordinates or x and y values that are already complete to calculate for the value of k. Which one? We can choose whichever one we are comfortable with. So let me pick 2 and 16. This means that our expression connecting is y equals k over square root of what? Of x. But we've been told that x in this case is 16. Sorry, we have made a mistake here. Let's say this is our y. Great. This is our y, and this is our x, so that you're able to follow nicely there. Let's do this. Okay, so the table here now has 2 on y and x on 16, then 8 here, then we have 1 here, and 8 over 9, and we have a here. Please differentiate, this is 9 and not a. Great. So let's continue now. The expression is y equals k over root of x. And when we go back to our table, our y is 2. So wherever there is y, we're going to replace it by 2. Then the k. Then our x, the corresponding value of x and 2 is 16. So we're going to have 16 in there. Right. So now we can cross multiply to find the value of k. So before we cross multiply, we know that the square root of 16 is 4. So we have 2 over 1 equals k over 4. And then when we cross multiply, k times 1, we have k equals 2 times 4, and we have our 8, which is the constant of proportionality of the inverse variation that we are talking about. And that is the value that we are asked to find. Having found this value of k, we can replace it in the expression or the equation connecting the variable y and the variable x, which is y equals k over square root of x. And now our k has been calculated as 8. So we're going to say y equals 8 over square root of x. This expression or the equation connecting y and x is going now to help us solve the other question, which is the value of a. When we go to our diagram there, the table of values, we have the y value 8 over 9, which is corresponding to the x value, and this is a. And we are being asked to find the value of a. So in the equation connecting the variables y and x, wherever there is x, we are going to replace by a. Fine. So here now we say y equals 8 over root x. But then we've been given that the y value or the value of a is 8 over 9. So we are going to say 8 over 9 equals 8 over square root of x. I hope you're able to follow there. Then we're going to cross what? Multiply. Because that is what the equation connecting the variable states. So when we cross multiply, we are going to have a situation where we have square root of x equals 9 times 8. Then we have 8 here because we are also multiplying there. Okay, then 9 times 8, this is going to give us 72. So we have 8 square root of x equals 72. And then we are interested to find the value of x. So we are going to simply divide throughout by 8 so that we remain with the square root of x equals 72 over 8. But we also know that when 8 goes into 72, this is going to give us 9. And so we have square root of x equals 9. We haven't been asked to find the value of the square root of x. The question reads, find the value of x. But the value of x is embedded in the radical, which is the square root sign. How do we get rid of the square root sign? We are going to introduce the square roots to both sides, such that this square and this radical, the square root sign, is going to be eliminated. Then you remain with your x, which is equal to 9 squared. And 9 squared is 9 times 9, and 9 times 9 give us 81. That's the value of x. Right, I hope you are able to follow that question on variation. So every time when we're dealing with questions on variation, remember there are different types of variation: direct variation, inverse variation, joint variation. When two variables vary in such a way that when one increases, the other one decreases, they are in inverse variation. When one increases, the other one also increases, they are in direct variation. But if they are varying in such a way that one is connected to the other, or two or more quantities are connected to each other, either by direct or inverse variation, then they are in joint variation. Let's move on to our next question. And our next question is question 15, which is also important that we look at it this morning and see how best we can gain the confidence that is required of us in answering such questions in the final exam. All right, so the next question is on social and commercial arithmetic, which is also a topic that has been included in the revised curriculum, and most of the students are having a lot of problems with this topic because they keep on complaining the topic is very bulky and there are a lot of things to be done. But the beauty of this topic is that it can be applied in real life situation. We can see how we can apply in a real life situation. It is real, not the mathematics that just remain in a classroom situation. So let's read the question here. Mafoni Manufacturing Company paid a total dividend of 12,600 kwacha at the end of 2015 on 6,000 shares. So we have a situation where now here 6,000 shares were bought at 12,600. I hope you're able to follow there. Let's end there and then see the next part of the question. The next part of the question states, if Magula owned 200 shares in the company, how much was paid in dividends to her? So Magula owned 200 shares, and then we don't know how much was paid, so we say let's represent that by X. So this is simply a topic on proportion. The topic is on social and commercial arithmetic, but you need to use ratios and proportion for you to come up with a solution. So without wasting much of the time, we straight away cross multiply. So we have 6,000 shares X, which corresponds to 12,600 multiplied by 200 shares. And then this is going to give us 600x. When we cross multiply, we are going to say 2 by 6, we have 12, carry 1, 2 by 2, 4 plus 1, we have 5, then 2 by 1, we have 2, but we have these 2 zeros, so we are going 4 zeros, we're going to add them there. The next, since we are looking for the value of x, which is asking us to find how much Magula had spent to buy the 200 shares, we are going to divide 6,000 throughout, also by 6,000 here, so that we have x equals, now you can see that this will eliminate, this and that will also eliminate, this and that one will also eliminate. So when we say 6 into 25, we are going to say this is 4, remainder 1, and 6 into 12, we have 2, and plus, this is 12,600, okay, then we are going to have our x, which is going to be 42 kwacha. So meaning, Magula, 420 kwacha. Magula, if Magula owned 200 shares in the company, how much was paid out in dividends? So 420 kwacha was paid out in dividend to Magula. So that's the question for you on social and commercial arithmetic. Right, so we move on to the next question, which is B. The next question, B, involves some concepts to do with trigonometry. It reads, the diagram below shows triangle ABC in which AC is equal to 8 centimeters. Angle A, look at CAB. The letter which is in the middle represents the angle. So that symbol or that sign you are seeing on top represents the angle. So CAB, there in short we can say angle A equals 30 degrees. And angle B, now they're saying ABC equals 90 degrees. So we have a sketch of this diagram like this. And it's a right angled triangle here. Already it has been ascertained, and then we have A here, we have B, we have C, and then we have 30 degrees here, and then we have 18, and then we have this AB, which is not yet found, but they are asking us to calculate the value of BC. Now, when you look at a right-angled triangle, we have ascertained to say the side opposite, the side opposite to the angle is the opposite. The side which is opposite to angle 90 is the hypotenuse, and this side will be the adjacent side. So we can use either trigonometry or we can use Pythagoras theorem in order for us to come up with the given asked question, which is BC, to calculate the side BC. But in this case, since we have an angle 30 degrees, we are going to use trigonometry. So since it's a right angle triangle, we have in mind the three trig ratios that apply in the right angle triangle: the sine, the cosine, and the tangent. I guess you are able to remember this when you did trigonometry in grade 11 at secondary school. So cosine and sine. So what does sine state? Sine states is opposite over hypotenuse. I'm sure you're able to remember the mnemonic, which is called SOHCAHTOA. SOHCAHTOA. You remember this? I want to believe you remember this at school. Your teachers had taught you. So SOHCAHTOA, this is just a mnemonic standing for sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and TOA, which is tangent, is opposite over adjacent. Now, when you look at the information given in the diagram, we have the opposite and we also have the hypotenuse there, meaning we are going to use one trig ratio, which is sine. So we are going to say sine equals opposite over hypotenuse. So sine theta equals opposite over hypotenuse. So what is the sine which is in the diagram here? The angle given is 30. So we are going to say sine 30 degrees equals, what is the opposite? The opposite is simply the side that we've been asked to calculate, and this is BC. So we are going to say BC over, what is the hypotenuse? The hypotenuse, which is the longest side in this triangle, is simply 18. Now, we can cross multiply to find the value of BC. So BC now equals to sine 30 degrees times 18. When you go to special angles are simply angles that have been given numerical values, which you can use easily to replace and solve the problem that you've been given. And under special angles, sine 30 degrees is equivalent to 0.5 or half. So where there's sine 30 degrees, we are going to say BC is going to be half, or 0.5 times 18. And so, BC is going to be 2 here, 2 there, 9, and the length of BC is going to be 9 centimeters. So that is how you are expected to answer that question on trigonometry. It's a simple trigonometry which does not need you to use a calculator for you to find the answers as it is being presented in the question paper. So now we move on to our next question, which is question 1 in the same paper 1 of 2017 General Certificate of Education. Okay. The first question is simple. First of all, in an exam, you need to understand that questions have been prepared in such a way that you start with something that is motivating you. And when you look at question number 1, it is something that even people in lower grades are able to do it. But usually students make some mistakes here and there because of the operations that are involved in the working out. So let's look at question number 1. Question number 1 states, simplify 2a minus 7b minus 2, then a minus 3b. What is to simplify? Simply to make something look simple. It looks complicated because we have got terms, some are in the brackets, some are not in the brackets, and when you look at them, they have not been orderly done, so you've been asked to simplify them. So how do you simplify? First of all, you need to expand that which is in the brackets. So what is in our brackets? We have 2a minus 7b, And then we have negative 2 here, which is being distributed to all the terms in the brackets. And that is where most of the students make mistakes when it comes to expansion. So what are we saying here? Negative 2 times a, we are going to have negative 2a. But please be careful there. There are two operations. There is this operation and this operation as well. This operation is being distributed to that. So, okay, we say negative 2 times negative 3b. So we'll not rush into putting a negative sign here because the negative and the negative will give us a positive, and then 2 times 3b, we are going to have 6b. Right. Now that we have expanded and removed what is in the brackets, we are going now to collect the like terms so that we simplify the given expression. So, 2a minus 2a, then we pick this negative 7b plus 6b. So 2a minus 2a, this is going to eliminate. So we remain with negative 7b plus 6b. And negative 7b plus 6b is the same as negative b. Some people wonder how come this is the same as negative 7 plus 6, which is negative 1. But we have algebraic expressions here, expressions that have letters attached to the numerical values. And so that's how come instead of negative 1, we are having negative b. That is how best you would have answered that question, which was question number 1. Right, for now we are going to go on ad break. Please remember to comment and also tag your friends and family. Once more, my name is Anton Samanenga. I'll join you after 2 minutes. Please stay tuned.
Without music, our lives would be lifeless.
Music gives the mind wings.
Music refreshes the soul on this journey of life and never dies.
It's who we are. I mean, it's what we do.
It's what we feel.
What would we be without music?
The future of music streaming is MTN Music Plus.
MTN, everywhere you go.
In Teleschool, we continue from where we ended and revising the question. Thank you so much, Imusunga, Obed, Muviana, Anton, Isaacs, for the comments that you are bringing forward. We continue to look at question 2. Question 2 states factorize completely. Factorize completely, then we have x squared over 4y squared minus 1 over 9. What is to factorize? To factorize is to simply express an expression as a product of its factors. So there are different types or ways in which we can factorize an expression. We can factorize it by difference of two squares. We can factorize it by grouping terms, and so on and so forth. Now, when we look at the given question, we have this operation, which is subtraction, a difference. Now, we also have terms like 9 and 1 over 9. 1 over 9 is the same as 1 squared over 3 squared. Then we have x squared and 4y squared. This 4 can be expressed as 2 squared. So we can see that this whole expression can be rewritten as x squared over 2 squared y squared minus 1 squared over 3 squared. This is a difference of 2 squares. So factorizing a difference of two squares, in order for us to find factors, two factors, when we expand them, we get back to the original expression given. We are going to simply open two brackets like that, and then say we have x here over 2 because we have x squared, so meaning we have 2x, and then 2 squared, meaning we have 2 2's, and y squared, meaning we have 2 y's. So one remains here, then the other one is x over 2y. Let's get back to the other expression, the other term here, which is 1 squared and 3 squared. So the other one will be here, and the other 3 will be here. Then the other one will also be here, and the other 3 will be here. Now, since it's a difference of two squares, it means one factor can either be positive and the other factor can either be negative. But there is no harm in interchanging them. You can either write x over 2y minus 1 over 3 and x over 2y plus 1 over 3. There's nothing different between these two factors. It's just like doing 2 times 3 is the same as 3 times 2. So you have factorized completely to come up with the two factors or two expressions. When you expand them, you'll be able to get back to the original equation, which was given as x squared over 4y squared minus 1 over what? Over 9. Right, so let's move on now and go to look at another question. Our next question is question number 3, and this question is on matrices. A matrix is simply a rectangular array of numbers. We know that basic information about matrices. So we have the equation given as 2x and negative 5, then 1. This is a matrix. Then we also have 4 and 3, which is equated to 4 and negative 17. Negative 17 like that. Then they are asking us to find the value of x. How do we find the value of x in that situation? So this is multiplication of matrices. When you are multiplying matrices, there are certain things that you need to put into consideration. The order of the number of rows should be, you can see that the order of this first matrix is 2 by 2. We have 2 rows and 2 columns. So multiplication of matrices is done by row by column. So we have the row which shall multiply the column. So if I multiply the first row and this column, I'm going to obtain 4. So let's try and do that in the quest to find the value of x. So we have 2 times 4. We are going to have 2 times 4 plus x times 3, which should give us 4. 2 times 4 plus x times 3 equals 4. I want to repeat here, whenever we are multiplying matrices, it's done row by column. So I multiplied the first row and the column to get the answer, which is 4. If I'm to multiply the second row and the column, I'm going to get the answer, which is negative 17, that has already been found. But then in the first row, we've seen the variable x, and we've been asked to find that value, the value of x. So 2 times 4 gives us 8 plus x plus 2 times 4 plus okay. All right, so we continue from where we ended. We have the question 2, we have the question on matrices 2x.
Rise up this morning, smile with the rising sun. Three little birds pitch by my doorstep, singing sweet songs, our melodies pure and true, saying, this is my message to you. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Cause every little thing is gonna be alright.
How you use your data is up to you. With the widest network coverage, it's amazing what you can do on MTN.
This is my message to you.
Continue with the question that we were looking at. We are looking at a question on matrices, and the question was given as 2x, -5 and 1, then 4 and 3 equals 14 and -17. We've been asked to find the value of x, and in this case, we are multiplying two matrices. And whenever we are multiplying two matrices, we need to bear in mind that matrix multiplication is done by row and column, row by column. So the first, we have this row, which will multiply this column. And since it's the first row, we are going to, since it's the first row, our solution is going to be 14 here. And again, when we multiply this and the column here, we are going to have our answer to be -17. Now, the first row has a variable x, and the question has asked us to find the value of x. So we are going to say this row times this column equals 14. And so we shall say 2 times 4 plus x times 3 should give us 14. If we also go ahead and multiply the second row and the column, it will be equated to -17. But we'll not go to that extent, because we know that in this row, we don't have any variable that we need to calculate for. So now let's simplify this. We have 2 times 4. 2 times 4 is giving us 8 plus x times 3. This is multiplication again, I beg your pardon. X times 3, this is a 3x equals 14. Now we have obtained a simple arithmetic or mathematical equation, which is a linear equation which we can solve without problems. So we are going to transpose this 8 to the other side. So we have 3x equals 14 minus 8. Right. So we have 14 minus 8. So 14 minus 8, we have 3x equals, when we substitute 14 minus x, we are going to have 6. And 3, we divide throughout by 3, we are going to have x equals 3 into 6. What do we get? We end up getting a 2. Okay. So that is the value of x. Meaning, if we are to replace these two where the x is, we are going to find the matrix that is going to give us the 14 that we have already found. Right, so again, we continue. I think you did not have a lot of problems with that question. We want to continue and go to the next question. Question number 4. Right, so question number 4 is on similarity and congruency. It reads, if I can read the question together, let's read the question together. Two tins are geometrically similar if the ratio of their volumes is 27 to 64. Find the ratio of their curved surface areas. So two tins are geometrically similar. So we have the ratio of their volumes is 27 to 64. So we already know that volumes, the units for volume is a cube or cubed. And so to find the ratio of their volumes, we are going to introduce the cube root to both sides. And the cube root of 27, we are going to have a 3, and the cube root of 64 is 4. Meaning, when we multiply 3 by itself 3 times, we'll get 27. Multiply 4 by itself 3 times, we'll get 64. That's why they are saying if the ratio of their volumes is 27 to 64, then find the ratio of their curved surface areas. Curved surface areas, and now here we're talking about area. Area is always, the units for area is square units. And so to find the ratio of their curved surface areas, we are simply going to square the ratio of the volumes of these two geometrically teams, which is 3 squared to 4 squared, and we'll have our answers 3 squared, which is 9, and 4 squared, which is 16. So it doesn't break any bones. It's as simple as that. So even when you go and read more on similarity and congruency, you are going to experience this which we have experienced. So we move on to the next question. The next question is question number 5. Question number 5 is on, just a minute, let's clear this so that we can have enough time to work out this problem. Okay, so the next question, question number 7. I said question number 5, but we're going to look at question number 7. And question number 7 is on series and sequences. Series and sequences. So in the old curriculum, we only concentrated much on series and sequences. But in the revised curriculum, there's an addition of arithmetic progression and geometric progressions. And these concepts come out clearly in paper 2. But in paper 1, we'll try and see how we can prepare ourselves for paper 2, which looks at arithmetic progression and also geometric progression, which is called the APs and the GPs. Right. So question number 7 states, for the sequence is 11, 13, 15, and 17. Find the 13th term. This is question part A. We have the sequence 11, 13, 15, 17, and it continues. So already we have the terms 1, 2, 3, 4. We've been asked to find the 13th term of that sequence. How do we go about the 13th term or calculating the 13th term of that sequence? We need to also understand that the first term is called A, but we also need to find the common difference, which is called the CD. What is the common difference? The common difference is simply the difference between the terms. And so when I subtract the first term from the second term, I'll have 13 minus 11, I'll have 2 here. 15 minus 13, I'll have 2 here. 17 minus 15, I'll have 2 here. This is the common difference. So the common difference in this case is 2. And in order for us to find the 13th term, we are going to apply the formula of the nth term, and the nth term is given by A plus n minus 1 and D, where A is the first term and D is the common difference. N here represents the term that has been mentioned in the question, and in this case they are talking about the 13th term. So replacing in the given formula, we are going to say A plus n minus 1D then our A is 11 plus our N, that is the 13th term that we've been asked to find. So we're going to say 13 minus 1, and the common difference which has been found is 2. Is 2. Sorry about that. So we are going to say we have 2. So we are going to put our 2 here. Then we simplify the given expression. 13 minus 1, we simply have 11 plus 12. Then we need to multiply it by 2. And then 2 times 12, here we're going to have 11 plus 24. And if we add 11 and 24, we are going to have 35 as the 13th term. So if we are to list down the sequence, we are going to discover that from the first term, 11, 13, 15, 17, going on, the 13th term is going to be 35. Right, so let us look at now the next question. The next question states, if the arithmetic mean of 5 and C is 11, what is the value of C? If the arithmetic mean of 5 and C is 11, what is the value of C? So here we have two numbers, 5 and C, and the arithmetic mean gives us what? 11. Now they want us to find the value of C. To calculate the arithmetic mean is to simply say 5 plus C, we divide by 2 and then equate it to 11. And this will simply, if we cross multiply, we are going to have 5 plus C equals 22. Because 11 times 2 gives us what? 22. We've been asked to find the value of C from this arithmetic mean of 5 and C. So here we are going to transpose this 5 to the other side, or add the additive inverse of 5 to both sides. So in other case we can say 5 minus 5 plus C equals 22. Whatever we do to this part of the equation is what we do to the other part of the equation. So we have also minus 5. That is what it means, adding the additive inverse of 5 to both sides. If we had here as negative 5, we are going to add positive 5, which is the additive inverse. So now we are simplifying everything by saying we transpose this 5 to the other side. Please, it does not jump nor cross the equal sign. We add the additive inverse, or even add additive inverse, or we say we transpose. I know most of us students, we are used to saying when it crosses the equal sign, it becomes negative, or when it jumps. There's nothing like jumping, there's nothing like crossing. We are simply adding the additive inverse to both sides. So here we have this and 5 and negative 5 eliminating. So we have C equals 22 minus 5, and then our C is going to be 17. Right. So that is what you are expected to do on question 7. It is based on sequences and a little bit of arithmetic progression, but more of arithmetic progression and geometrical progression is brought in paper 2, that which we are going to look at later in the day this afternoon. Okay, so now we move on to our next question, and that is question 8. Question 8 is also an interesting question. Question 8 is also an interesting question. I must mention here that we are just from doing one topic on matrices, and question 8 also has brought out that concept again in terms of matrices. And it reads, if A transpose equals 1, neg 2, 1, neg 2, 3, neg 4, and 5. When I say neg 4, neg 5, I'm simply talking about negative numbers. So A transpose, what do you understand by transpose? When you've been asked to transpose a matrix, they are simply asking you to change the rows into the columns. That is what simply they mean. So this matrix A has already been transposed. And when it was transposed, after transposing it, it became 1, -2, 3, -4, and 5. Now the question states, write the matrix A. How was the original matrix before it was transposed? That is what simply means. A transpose is this matrix that has been given. But what will be matrix A? What will be the original matrix? What did they do for them to obtain the transpose of this matrix? And so, as I earlier on alluded to transpose a matrix is to simply change the row into the column. So here we have a 1 by 5. The order of this matrix is now 1 by 5. 1 row and 5 columns, because we have this column 1, column 2, column 3, column 4, and column 5. So in order for us to revert to the normal matrix that we are given of A, we will change the row into the column. And this is going to be A equals 1, -2, 3, -4, and 5. So this was the original matrix. And when it was transposed, we'll end up having the matrix which is above there. So that is simply what it meant to say, can you transpose this matrix? Right, so we move on to another question, which is question part B. Question part B. Question part B is also interesting. Question part 8B. It's on calculus. Whenever we talk of calculus, a number of students out there feel, what animal are these people talking about? What is this calculus and all that stuff? They are saying, find the derivative of y equals 2x cubed minus 2x squared minus 3x plus 1. In other books or in other questions, they may ask you to say differentiate x with respect to y. Differentiate x with respect to y. If they don't say differentiate x with respect to y, they will simply ask you the way they have asked, can you find the derivative of this function y equals 2x cubed minus 2x squared minus 3x plus 1. Now, what do you need to have in mind when you're solving questions of this nature? You need to have some basic understanding of calculus, integration. This is, differentiation. This is just based on differentiation. What rules are there for me to differentiate? Whenever you are differentiating, there is the 2 here and the 3, the power here. So in order for us to find the derivative, this 3 multiply the 2, but it will be lessened by 1. Also, this will multiply by 2 and will be lessened by 1. And there is the power is 1. This 1 multiply this, and if it's lessened by 1, we are going to have a 0, and x to the power 0 is 1. Any number raised to power 0 is 1. And this, when we differentiate 1, it becomes just a constant, so it will not have an effect to the equation that we've been given. So once more, we have y equals 2x cubed minus 2x squared minus 3x plus 1. You may not need to memorize the formula or what's the formula for differentiation. Have an understanding that if I'm finding the derivative of y, I'm going to say dy over dx. Now, this is, we multiply 3 times 2, we are going to have 6x, but the 3 will lose a power, so it will be 2 here now, minus 2 times 2, we have a 4x, and this 2 will lose a power 1, and then we have 1, then minus, the power here is 1. When we also subtract 1 times 3, is 3. So this is the derivative that they're looking for. So you have found the derivative of y equals 2x cubed minus 2x squared minus 3x plus 1, which is given as 6x squared minus 4x minus 3 as our dy dx, meaning we have differentiated x with respect to y. Okay, so now we move on to our next question for this session. I'm sure this is going to be our last question for this session, and then we want to see your comments there. Bring them forward. Please, as you watch, remember to tag your friends and family so that they can also join us in this live streaming. For those that are still busy and feel they need to watch this live streaming will be on MTN TV Plus, and that is just after an hour of this live streaming. You can watch the full videos of the presentations that we have made today. Right, so the last question is question number 9. Question number 9 reads, it's on sets, and we have been given that the universal set equals 1, 2, 3, 4, 5, 6, 7, and 8. Okay, then from the universal set, 2 sets have been formed, and this is set A, which has elements 1 and 8, and set B has elements 2, 3, 4, 5, 6, and 7. So from the universal set, we have formed 2 sets, A and B. Also, we need to caution each other here that whenever we are denoting sets, we denote sets with capital letters. We do not denote sets with small letters. So once you denote them with small letters, there's something else in mathematics and not sets. So what does the question state? The question states, list A union B complement. List A union B complement. What do we understand by a complement of a set? Here, we need first to list what is A union B. What are the elements that are found in set A and in set B? All the elements found in A and B. So A union B, we have 1. We can write them in order. So we can say 1, we have a 1 here. Then we have a 2 there. Then we have a 3 there. Then we have a 4 also. We have a 5. We have a 6. We have also a what? A 7. And we have a what? An 8 there. These are the elements of A union B. But the question is asking us to find elements of A union B complements. So what elements are not in A union B? So those are the elements that we want, but they are found in the universal set. So in A union B, we have 1, 2, 3, 4, 5, 6, 7, 8. What elements are in the universal set? We have 1, 2, 3, 4, 5, 6, 7, 8. So A union B is simply an empty set. Please take note. Don't write A union B is 0. 0 is an element. So immediately you put 0 in the union set, in this set, then you are telling everyone that A union B complement is 0. There is an element which is 0 and it's not found in A union B. So don't write 0. Simply write A union B complement equals the empty set, or you can write it this way. You need to be clever here to realize that this is what they mean. Question part B. Question part B states, solve the equation 25 raised to power x equals 5. 25 raised to power x equals 5. Right, so this topic is based on indices. And indices we need to remind ourselves what indices are. If I have 2 to the power 5, this 2 is called the base, and this 5 is called an index. So, we are looking at indices. The plural for indices, index, is what we call indices. So now, in this question, we are solving equations or involving indices. And we have a question, the question 25 to the power x equals 5. There are some rules of indices that we need to put into consideration, such as when multiplying powers of the same base, you add the powers. When dividing powers of the same base, you subtract the powers. So I can cite an example to say, for example, if we have a to the power m times a to the power n, the bases are the same, so we add the powers. This is the same as a, then m plus n. We also have, if for example we are saying a to the power m is being divided by a to the power n, the bases are the same, and we are dividing powers of the same base, we are going to say a m minus n. So those are some of the rules that you need to understand when dealing with indices. When you are multiplying powers of the same base, you add the indices. When you are dividing powers of the same base, you subtract the indices. There is also what we call power of the power. So in order for us to solve this equation, we have 25x equals 5, right? The bases are different in this case. Here we have 5, here we have 25. So it's not easy to straight away go ahead and solve this problem. You need first to convert the bases to be the same. Is it possible to convert 5 to base 25? It's practically impossible. By the way, this 5 is raised to power 1. Now, it's possible to convert 25 to base 5. And 25 is the same as 5 squared. Then we have x equals 5 to the power 1. So you can see now that the bases are the same. We have not changed anything here because 25 has been expressed as a product of its as a square, so it's 5 squared. So we have 5 squared. Here we are applying the rule of multiplication. We're saying 2 times x. We are going to have 5, and then 2x equals 5 raised to power 1. Now that the bases are the same, it puts us in a better position to straight away equate the powers by saying 2x equals 1 because 5 is raised to power 1. And having this simple equation only puts us in a better position to smile and say, wow, if I divide by 2 also, and also divide by 2 here, I'm going to have x equals 1 over 2. And this is the value of x that we are asked to solve for. Now, you can also verify to see if the value of x that you have found is correct. Let's go back to the question. The question reads 25x equals 5. So the value of x is half. So it's the same as when we raise 25 to power x, we are going to find the answer 5. So we want just to verify. We just want to verify if this value of x we have found is correct. So we are going to say 25 raised to power 1 over 2. And we can express 25 as a square. We are going to have 5 squared and also 1 over 2. And so you can see that this power and this power, they are multiplying. So we have 5, then 2 times 1 over 2. This is over 1. So you can see that this one and this 2, they're eliminating. And the 1 and the 1, they're also eliminating. So you end up finding the answer 5, which is true that when 25 is raised to power half, the answer is going to give us 5. So that is what you needed to do on that question. Thank you so much for joining us. My name is Anton Samanenga. Join me again at 14 hours when we are going to look at the next paper, which is paper 2 in mathematics. Please invite as much as of your friends. We have seen comments from Akim Munyirenda there, who is based in Russia and is following and loving the presentations, and many more others that are bringing in these comments. Please bring them on so that we can continue getting feedback from you. For now, stay tuned and bye-bye.
Oh, tiende pamozi ni mtima umo, 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 tiende pamozi ni